Hi, this is Crystal, and this is for my belt drive lab for motors and drives. So here I have the system, where I have a 4.5 diameter, 4.5 inch diameter sheave, and a 5.5 diameter, 5.5 inch diameter sheave, and here you can see the angles of alignment. So I would say that they're pretty aligned. Um, and so what we're going to be doing is we're going to turn it on. And we have this at 10 hertz, so it might be a little slow. And this is how fast it moves. So we're going to take the RPM, and what I calculated for the little one is, or what I got for the little one is like 281.1. So I got on RPM photo. There it is. And then for the big sheave, I got 255. There it is. I moved a little so it did that, but yeah. And so now we're going to turn that off so that I can teach you how to tension the belt. And we're going to wait a little bit. Okay, now that it's turned off, I can show you how. First, we need something that's long enough and that is straight. So like this. I can't keep it in here with just one hand, so I'll just leave it like that. But here we have what is called a belt tensioner. And so this chart has a image of how we want to like tension the belt. If you can give me a moment. Okay, so here I have it all held down. So this is basically what we want to do. So we want to put the flat side of this, and this side is for like normally we'd have a rubber ring here, but we don't. So I marked it a little bit with a line, but it's not there right now. And you have to push the little ring to 0 because this will be how much like force it's measuring, but we want it in pounds. So once you move the rubber ring to inches of span, we want to do what the photo is showing. So we grab that straight edge that I was talking about, and then we press down like this until it reaches the big black rubber ring. So there's a more better version here. And so that's what I'm going to do. And we also have to look at the belt drive at the belt to be able to see what type of belt this is. So it says B2D. So we go to the chart and we search B, and our smallest sheave is 4.5. Our biggest 5.5. So This one will, in the middle, will be good. And we're using inches and pounds, so we'll stick with this side. And RPM range, it says 860 to 2500, so that's good. And it says that we should get a pound force of 5.3 or 7.9, like in the middle of those two. So let's go to the belt drive and put the straight edge the best how I can. I'm going to mark this. Also, what I forgot to mention is that when we move the rubber ring, we want to move it to where our center to center distance is. So we'll grab like a ruler, though this is not a ruler, but it's not long enough either way. But we like grab it like that, and then we measure like in between like the middle of here to here. So just like that. And then the value I got was like 12.5 or 13.5 inches. So then that's where we moved the rubber ring. And now I'm going to like press it. Although I can't get it good, I'll put my finger here, move down the O-ring to the back to back where it started. And then I'll be with you guys shortly. So once I did that, we're going to look at the little ring at pounds. And I can't get it to read right, but it's between the 5 and the 10. So that means we're in good range. And the belt is tightened properly. So that's how you tension a belt. And also, I wanted to mention that this coupling right here is a sleeve flex coupling, and the reason I chose it is because it's easy to install. It dampens vibrations. It controls shock, and it also handles all axis misalignment. But the only like cons is that you can't use it for like I believe really heavy loads or high speeds, but it's okay for medium and slow speeds from what I gathered. So if I'm wrong about that, please correct me. But other than that, that's what I believe is the use for the sleeve flex coupling. And the system's effect on torque and speed, I'd say, is that since we have this little one here and this big one here, if we brought this to the middle like that, and we do one, or actually, if we bring the big one to the middle like that, and then we turn it one time, we can see that the little one has spun a lot more than the big one, because the little one has less like distance slash the circumference that has to cover. But this one, since it has a bigger circumference, it has like more surface to cover. and that's why it takes longer to or it takes more spins from this to get this one to spin one time. So if we do it this way, we see that here is one time. And we can see that it hasn't gone up yet. So we need to do a little bit more. And that's one full revolution. So thank you for watching and have a nice day.